Hello, everyone. This is Shauna, and I'm coming to you today with a partial walkthrough of section 4.3, and I'm hoping to help you specifically with some of the tree diagrams in this section. There's a lot of concepts in this section, including independent and dependent events and conditional probabilities. So I want to try and address that, but within the context of doing some tree diagrams, which some of you had asked for some help with. So let me share my screen at this time. And let's take a look. So 4.3, the multiplication rules and conditional probability. Okay, so we've done the addition rules with OR. So here, two events, A and B, are independent if the fact that A occurs does not affect the probability of B occurring. Now, always there's confusion here, and understandably so, between, excuse me for that, there's always confusion between independent events versus mutually exclusive events. This is always a confusion, okay? Now, mutually exclusive events, as we saw in the last section, mutually exclusive events cannot happen at the same time. They cannot. That's what mutually exclusive events mean. They're mutually excluded. So in a picture, it looks something like this. Let me draw. This is a loosely constructed Venn diagram. We have a rectangle, and then we have two circles. So we have something like, here's a circle. Okay, there's a circle there. And there's another circle over here. Let me draw another circle here. These are pictures of mutually exclusive events. Set A and set B are mutually exclusive events. Okay, that's what mutually exclusive is a picture of. Okay, this is mutually exclusive events. All right, now independent events aren't focusing on the sample spaces. They're focusing on how likely one event is versus the other, and whether the probability of one happening makes the other event more likely. Okay. And this will get clearer to you, I think, when we start talking about hypothesis testing later in the book and we talk about dependent situations, but I'm going to try and clarify this now. So independent events do often occur together. So they are not mutually exclusive, but here's the big but their likelihoods are not affected by each other. Now, here's an example, okay? Now, consider this example. Event A is is going to the library. And event B is having blonde hair. Now, do they have an impact on each other? If you go to the library, are you more likely to have blonde hair? Or if you have blonde hair, you're more likely to use the library? They don't affect each other. Those are independent events, okay? They're not mutually exclusive, but they are independent, okay? And we have a formula to determine independence, just like we have a way to determine mutual exclusivity, all right? We'll talk about that later. But independent, so for example, here's an example of dependent events. Dependent events affect each other's probabilities of occurring. Okay. So for example, event A is staying up for 24 hours. And event B is feeling grumpy in the morning after you stay up. Those are dependent. You're more likely to feel grumpy in the morning if you stay up than if you don't stay up in the morning, right? People can feel grumpy whether or not they stay up. Maybe they do, maybe they don't, but you're probably more likely to feel grumpy if you've stayed up for 24 hours. Those might be dependent events. There are other examples, but that's what we're talking about here. Okay. So I hope that clarifies a bit. Now, what I really wanted to focus on in this video is more about tree diagrams. We saw in the previous section that tree diagrams can help us with finding sample spaces. So one thing tree diagrams can do, tree diagrams can help us determine sample spaces if the number of outcomes is small, okay? If you have a large number of outcomes, we have counting rules for that. We have other ways that we deal with that, which we'll see about more in the next couple of sections of the chapter 4. But for right now, I wanted to come back to a problem that we did in 4.1, or maybe this was 4.2, but it's the problem says this. The problem says, I believe this was in 4.1. 4.1, number 18. Here's my problem. It says, a box contains a $1 bill, a $5 bill, a $10 bill, and a $20 bill. Okay, and it says that a bill is drawn or a bill is selected at random and not replaced. A bill is selected at random and not replaced. Then a second bill is selected. Okay, we want to draw a tree diagram to illustrate the sample space. Okay, so here's where we are. All right, this is the problem that we have. Let me widen the text box so it doesn't take up quite as much room. Now, a couple of things about drawing a tree diagram. Some of you are like, how do I start? How do I know how many branches to draw? Well, again, as I said, start a little ways down on your paper under the words, give yourself some space. Now here, we know we have a $1 bill, $5 bill, a $10 bill, and a 20. So we have 4 choices here. A bill is selected at random. So we know we have 4 choices. So our first choice, I'm going to draw a dot here. And there's going to be 4 rays that come from that dot. Okay. So I'm going to draw, here's a ray. There's a ray there. Draw a ray here. This is another ray. Oops. And then we're going to draw another ray down here. And another ray here. Okay, so this you have to play around with a little bit with this. But sometimes you have to kind of, and you might have to extend this. I'm going to do the best I can here on the screen. You have a little bit of an extra chance if you're doing this by hand, but I'm going to do my best here. These are my rays, okay? They don't have to be equally spaced, but it kind of helps. But this is your situation, okay? So this is your first draw. So this is my first bill, okay? Now, what options do I have? Well, I have a $1, so I'm going to put $1 here. And then I have a $5 bill right here. And then I have a $10 bill here. So I have a 10. And I have a 20. Okay, 20. Now, my second choice, it says, this is important, it says not replaced. That means that I went in and I drew a bill, I drew one of these, and I didn't replace it. So now, whatever I chose, there's only 3 bills in the box. If I chose the $1 bill, right, then I only have 3 options left here. I have my second choice. And then I have a third choice here, right? Now, again, if I did the 5, I have 3 choices. I have I have to, takes a while to draw these on the screen. Bear with me for a minute, okay? For my 10, I don't need to extend it quite that far because, but I just want you to see it because it takes a little longer to get out there. And this is, like I said, this can be hard to draw to scale on the screen, but you're going to have that one. And then you're going to have your 20. So here you have your bill, okay? So this is going to be my tree, all right? So here I've got, now, if I drew a 1 the first time, I don't have the dollar bill in there anymore. Now I have the $5 bill. Excuse me, the $5 bill, the $10 bill, and the 20. Okay. And then I have, if I drew the 5 the first time, then I have the $1 bill. Remember, I don't have the 5 because I drew it here. So this is the $10 bill. And the 20. Okay. Here I have the $10. This is the $1 bill. So I have the 1, I have the 5. Oops. And I have the 20 on in here. And if I have the 20, then I have the 1 here, the 5 here, and I have the 10. So now, if I want to set up the sample space for this, I just follow the branches. So if I want to set up the sample space for this, I can say that my sample space is the following. It's going to be $1 and $5. $1, $5. Then I have $1, $10. And then I have $1 and $20. And then I have $5, $5 and $1. Okay. I have to pick the $5 with the $1. Again, remember, this is a different outcome. So $5, $1, right? So this is, oops, there we go. Then I have $5 and $10 and $5, $5 and $20, right? Then I have $10 and $1. I have $10 and $5. I have $10 and $20. And I have $20 bills now. So if I chose the $20 the first time, I can go back and grab the dollar, or I can go back with 20. I can go back and grab the $5, or I can go back and grab the $10. This is without replacement. They're not replaced. Okay, so this is not replaced. 20 and 10. And that's what we're doing with this particular problem. Now, there's other problems that will ask us to actually use these diagrams, whether they're replaced or not. We'll use these diagrams to calculate probabilities, and I'm going to show you one of those next. This one is one of the ones that always gets people, but I'm going to show you a practical application of the tree diagram from the next section, where we're going to do some work. So let me continue now. I'm going to give me another whiteboard here, and I'm going to bring up the description of a problem that I want you to see. So we're going to look right now at number 7. Okay, number 7 on this sheet. It says, in a recent year, 8,073,000 male students and 10,980,000 female students were enrolled as undergraduates. Receiving aid were 60.6% of the male students and 65.2% of the female students. Of those receiving aid, 44.8% of the males got federal aid and 50.4% of the females got federal aid. Choose one student at random and find the probability that the student is, and then fill in the blank, okay? So before we get to that, we're going to make a tree diagram. Now, one thing that I will point out that's different in this problem than it is in some that you'll see, and that is everything here, everything on this problem is a percentage except these two numbers, 8,073,000 and 10,980,000. Okay, I would highly suggest that you make these two groups percentages of the total. So we know how many students we have. We're going to add up these two numbers, and then we're going to find this in terms of percentages. Okay, so this is what we're going to do. We're going to bring up the calculator. I'm going to let it open, and we're going to pick up those two percentages, and I'm going to draw the tree diagram before I do anything else, so we can practice with that. So what I'm going to do now is I'm going to clear the calculator screen and make sure that I'm sharing the calculator here. So we have that I have this on a piece of paper next to me, the two numbers that I needed. So I have 8,073,000. So that's, I'm going to make sure also that my mode here, just for the sake of ease of clarity, is I'm going to make sure that my mode is on float so that I don't see decimal places. I'm going to put my mode on float here. What I'm going to do is I'm going to take 8,073,000 and I'm going to add 10,980,000. That together is going to give me, except I didn't add it correctly. Give me a moment. Let me come back. This number was incorrect. 10,980,000. I'm missing some zeros. There we go. So here's my number. There we go. It's 19,053,000. So my total is 19,053,000. So what I'm going to do here is I'm going to take my 8,073,000 and divide it by 19,053,000. 19,053,000. That comes out to about 0.424. This is 4237. I'm going to use 424. I'm going to do the same thing for the female. So this is 10,980,000. 123 divided by 19,053,000. 123. That comes out to 0.576. So now writing those two numbers down. So we have 0.424 and I'm going to use the decimal equivalents. You'll see why. So when I go to my screen, I'm going to go back to my whiteboard. Okay. Now we've done the percentages. So we have a total. Let me make a note here. We have 8,073,000 males. We have 10,980,000 females. Altogether, that gives us 19 million. And let me go back. 53,000. students. Okay. Now, we did the percentages. I'm going to do the tree diagram for you here. So first, I'm going to start with male, female. So I'm going to draw this tree, going to look slightly different. This is going to be male and female. Okay. Male, female, right here. Now, I'm going to put male on this branch, female here. Now, we just did the percentages. So the males were 0.424. And the females were 0.576. Now, if we go back to our problem, it says, I'm going to share the problem again. In a recent year, 8,073,000 male students, 10,980,000 female students were enrolled as undergraduates. Receiving aid were 60.6% of the males, 60.6% of the males, and 65.2% the females. Okay, so now we're talking about whether they got aid or not. So now, whether you were male or female, we're going to talk about aid versus no aid. So I'm going to have another dot out here. And I'm going to have on here, I'm going to have aid or no aid. Okay. You either had aid or you didn't. And if you were female, the same. You either had aid or you didn't. So here's the aid, or you didn't have aid. Okay. Now you write here, you write aid. This is aid. This is no aid. Okay. So you have aid, you have no aid, you have aid, you have no aid. Okay. Now, if you were male, it said that 60.6% of the males. So go to the males and find aid. It said 60.6% had aid. So I'm going to write that as a decimal here. 60.6% of the males had aid. That's this group. And it says that the females, 65.2% of them had aid. Okay, so that's this part. Now, you might be wondering, what am I going to do with this no aid branch? Well, the branches that are in pairs with each other have to add up to 1, male and female. These probabilities have to add up to 1. These probabilities, aid and no aid for male, aid and no aid for female, have to add up to 1. So what I'm going to do here is, to get this number, I'm going to subtract 1 minus 0.606. So what I'm going to do here is 1 minus 0.606. Okay. And that calculation is going to give me my no aid group. And that comes out, when you do that calculation, that comes out to, I don't have it listed, so let me share the screen here. So we have 1 minus 0.606. This is 0.394. So I'm going to come back and I'm going to write 0.394 underneath here. Now, I'm going to do the same thing for the females. We have, this branch is going to be 1 minus 0.652. So then if I do 1 minus 0.652, this is 0.348. Okay, so I'm going to say this is 0.348. Okay. Now we have one more group here, and that is federal aid. And I just know that because I've read the problem repeatedly. Let me go back and show you here. So we did the receiving aid where 60.6% of the males and 65.2% of the female. Of those receiving aid, 44.8% of the males got federal aid. 44.8% of the males got federal aid. And 50.4% of the females got federal aid. So now we're going to look at this. We're going to say, okay, that means that over here, now you have to be a little bit careful. We have to make sure we're on aid here. So we're going to make sure that we're on the aid branch. And we're going to extend this out. Just the aid. Now, we don't know anything about no aid, but we do know that it was either federal or not. So I'm going to say that we have, let me move this over to the top of the screen. So we either have federal aid. This is federal. Federal aid. And I'm just going to say for the, because it doesn't tell us, I'm going to put other. Okay. But here again, same thing with the females. I have federal aid or other. If they don't have aid, then I don't put anything. So this is going to be, federal or other. You can put non-federal if you want. I'm just going to put other here. Okay, that's how this works. So now, what percentage of the males who received aid got federal aid? Well, that was 0.348. 448. Okay. And of the females, that was 0.504. Okay, I'm going to drag it over here. All right. So now I can fill in this bottom if I want. Okay. I can fill in, because remember, they have to add up to 1. So once again, 1 minus 0.448. So this is 1 minus 0.448. And this branch is 1 minus 0.504. Okay, let's do those calculations, put them on our diagram, and then we'll be able to answer whatever whatever question they ask us. All right, we'll be able to answer that. So here, let's do our calculation. Let's go to new share, and we'll do some math. So this is 1 minus 0.448. That is 0.552. So that is this number. That is this number here. This is, let's see. This is 0.552. Whoops, 552. Okay. Now, I'm going to do the same thing down here with different numbers. Let me go back to the calculator one more time. 1 minus 0.504. And that becomes 0.496. So, excuse me, we're going to get 0.496. Now we're ready to answer whatever they ask us. So let's take a look at the actual problem. This is your tree diagram that you've created. All right. So now I'm going to refer back to this tree diagram as I answer the questions. So I'm going to put the answers to the questions on the next whiteboard, but this is your tree for this problem. Okay, so that's how that tree diagram looks. So not always does every branch have little branches coming off of it, as in the case of no aid down here, right? So let's look back at the question. So the first question says, find the probability that the student is male without aid. Okay, male without aid. So here we're going to do, I'm going to go to the whiteboard and I'm going to say, I want to find, for the previous question, I want to find the probability. So I want to find the probability that a randomly selected student is a male without aid. Okay, well, all right. That means you have to think that, you have to think about what you're doing here. This means a probability of a male and no aid, right? So in that case, we're going to look at our tree, all right? So we're going to look at our tree back here on our whiteboard. I'm going to look at our tree. Here's the males. Let me do a spotlight for you. All right. So here's the males, 0.424 without aid. Well, that's just going to be 0.424 times 0.394. Okay. Because it's male and no aid, right? Male and no aid, 0.424 and 0.394. So this is going to be okay. So we have 0.424, and we're going to multiply that by 0.394. And if we multiply those two together, we're going to go to the calculator. Your calculator is your friend. So here you have 0.424 times 0.394, and that becomes 0.167 if I round it to 3 places. So now this is equal to 0.167, or about 16.7%. Okay, that's part A. All right, so just pretty straightforward, male, no aid. Okay, let's look at part B. Okay, and this is something that is new in this section. Part B is a male student given that the student has aid. So male student given that the student has aid. So here, a male student, so we're going to say this. We're going to do probability of male given that they have aid. Male given that they have aid. Now, when you do a given statement, what this looks like in terms of a Venn diagram, not that you have to remember this, but this is where this comes from. What happens with this is that we're doing this. We're saying, here's our, let me draw some sets. So we have we have the group of males right here. And we have another group, let's say here. And in this case, what we're doing is we have an overlap in there, okay? We have an overlap, and I'm going to put it like that much, okay? Now, The reds are the males. So let me write this in. The reds are the males. And the green are the has aid. So this is A, for example, right? This is the aid circle, right? Now, given, here's the deal. Instead of looking at the whole sample space, all right? Instead of looking at the whole sample space, we're looking just at, we're given that they have aid. So instead of looking at this whole picture, we're looking at just this circle. We're looking at just the green circle, okay? So we're looking at this green piece. We have an overlap with the red, but we're looking at this green. So now a male, given they have AIDS. So what we're looking at is actually this, this portion, that's the overlap, okay? Not compared to the whole sample space like we were in 4.1 and in some of 4.2. Now we're looking at this overlap, this and, because this is male and aid, this overlapping crescent right here. This overlapping crescent, let me use blue. Let me use the, okay, so here, let me switch this out. We're going to draw, and I'll show you this. We're going to draw this. Now, this crescent here, right here, this crescent is the male students who have aid. These are males who have aid. Now, the difference with given that, because this is not just male and aid, it's male given has aid. So what happens is you look at the part where they intersect. This is male and aid, but you only compare it to the green, okay? So the formula, the way we would write this out is we would say this. This is equal to, if you were going to write the formula, you would write probability of male and aid, okay, divided by the now where are you focusing? You're focusing on the green, you're focusing on the probability that you have aid, okay? So we have to look at the probability of having male and aid, and then you divide by the probability to have aid in the first place. Okay, so let me show you this on the slides so you can see what you're saying. So here, let's go to this probability, okay? Let's scroll down. I'm gonna scroll past this. We're gonna scroll past the independence, right? We're gonna scroll past it now. If you have two events that are independent of each other, and you're dealing with, I'm sorry, conditional, you're dealing with this formula here. Probability of B given A, which is the second formula below it. Probability of A and B divided by the probability of A, because A is your condition. That's your given condition. This line means given that, and A is your condition. So A and B divided by the probability after the line. So here we have one more time. Let me come back to this here. Oops. We're going to look at our example. Okay. Probability of male and aid divided by the probability that they have aid. Well, if I go back a screen, male and aid is pretty easy. That's male and aid is, here's the males, here's have aid. So the top is going to be these two numbers multiplied together. 0.424. So the probability of male given aid is 0.424 and 0.626. Now, the probability that they have aid, though, again, federal doesn't matter. Okay, not yet, not for this question, but we do have two people who have two groups who have aid. The males who have aid and the females who have aid. So 0.576 and 0.652. Okay. So what happens here is we're going to have to take the sum of those two numbers, 0.652. All right, so this is going to look like this. We're going to say, come to the next whiteboard and we'll write this out. So this becomes, remember, the probability of being male was 0. This is equal to this is equal to 0.424 times 0.606, right? And we're going to divide that by the probability of having aid at all. Now that's going to match this first term, but it's also going to include the female. So 424 0.606, but we also need to add, that's the males with aid. So we're going to add the females plus, I'm going to stretch this line out because I need more space. All right, so now this is going to be oops. It's going to be 0.576 times 0.652. 652. Okay. Those are my numbers there. And we're going to work that out. Okay. So let's go to the calculator. Go ahead and write that down. I'm going to give you a second to write down that calculation, and then we're going to put it in the calculator. So we're going to go now to the calculator and put it in. So we have, what I'm going to do here is I'm going to open a parenthesis and I'm going to say 0.4, oops, 424 times 0.606, close paren. That's my top, okay? I'm going to divide that by close parent, open, 0.576. Actually, 0.424 times 0.606 plus 0.576 times 0.652. And if I did that right, let's see if I did, I end up with 0.4062. So here, let's go to this here. I'm going to scroll down and I'm going to look for, there it is, 0.4062. And that's where it came from. Okay. So we have about 40.6%. So this is my second part of this question. This comes out to about equals 0.406, or about 40.6, depending on how many places you round the decimal. If you round it to 4, you'll get our answer. That comes out to that part. Now, the last part of this question, there's one more part to this question. So let me bring it up on the screen for you. And we'll talk about it. This is, let me scroll back to the question itself. It says, find the probability that it's a female student or a student who receives federal aid. A female student or a student who receives federal aid. So here, this is probability of a female student or a student who receives federal aid. Now here, this is an example of non-mutually exclusive events. They overlap. These are overlapping events. So what I'm going to do is I'm going to write, this is the probability of being female plus the probability of receiving federal aid. Be careful, not just aid, but this time federal aid, plus, sorry, minus the probability of being female and receiving federal aid. Okay, so there's no conditional probabilities, but there are quite a few decimals in here. So let's look. Okay, we know what the probability of being female. So let me go back to my screen here. We know what the probability of being female is. It's right here. It's 0.576 according to my tree. Now, federal aid, I've got two sets of federal aid. I've got the males who receive federal aid, which are these three top percentages, and I've got the females who receive federal aid, which are these three percentages. Let me, so the males are, the males who receive federal aid are this, this, and that, right? Multiply all three. The females are going to be 0.576, 0.652, and 0.504. Okay. So that's, but these people, the females who receive federal aid, are going to be excluded. So what I'm going to have, you can see, let me go to my whiteboard and I'll show you. So we have the females. We know that this is, the females was 0.576. There they are. The people who receive federal aid, now I want to take out the females who receive federal aid. So I have both sets of federal aid. This is going to be, let's do the males. The males who receive federal aid are going to be 0.424, all right? And then I have 0.606. 0.606 and 0.448, because this is male, receives aid, receives federal, okay? Now I would have to do the females who receive federal. So this is going to be, but I don't want, see, the receiving federal aid would be also my females, right? Which would be 0.576. Let me scroll over, okay? Have to make more space in my text box here. 0.576, 0.652. And 0.504, but so these are my males, my females, my males who receive federal aid, my females who receive federal aid, and now I have to subtract off this portion, right? This is female. Then I have, this is males receiving federal, oops. Federal aid, right? And then I have my females receiving federal aid, but I already know that I'm removing those people because I'm taking off the females. So what I'm going to do is I'm going to remove these females, okay? So these are my females who receive federal aid at this point, because I need to account for that. So I'm just going to remove the females who receive federal aid. So I'm going to say minus, and I'm going to have the same group. So this is my female. Let me write it in. This is my females receiving federal aid. And I'm going to actually have to subtract that group. So I'm going to minus the same group. So all I'm doing is I'm saying 0.576 0.652 and 0.504. Okay. So I'm basically removing the females who receive federal aid. So all I'm really going to calculate is this 0.576 plus this group right here. Because the other group is going to get taken out. They're the overlapping group. Okay. Because the females and the males, some of them do receive aid. So this is what we're going to have. I'm going to write that down and we're going to put it in our calculator. 576. This is 576 plus 0.424, 0.606, and 0.448. So now let's go back and grab the calculator here. And we'll get on with it. So we have 0.576 plus 0.424 times 606 times 0.44. And if I got it all, I think so. I end up with 0.6911. Okay, so let's go back to here so you can see. And this is there it is, 0.6911. So here I have this calculation. I'll put it up here, is equal to 0.691 or 69.1%. Okay. And that's how we use tree diagrams when we want to calculate conditional probabilities, when we want to use it to do sample spaces. And so I hope that's helped a little bit in terms of using your tree diagrams. I'm hoping to put up another video about some of the problems in 4.3, but we'll see how that goes, and look for an embedded tutoring video probably sometime on Friday, because there'll be tutoring tonight. So take care of yourselves, folks, and I hope to see you very soon in another video. If you have questions that you would like me to answer, please feel free to either email me or comments below the video, and I'll be happy to answer that if I can. I'm going to stop sharing at this time. And I will be wishing you all a very good day and hoping to see you in my next video. Thank you very much. Bye for now.